Guys, this is the double check for section 3.4. I'll go through a couple of the examples with you. I'm going to move pretty fast on them, so obviously pause where you need to, and we can go from there. Part A, graph each polynomial function. Obviously, if it's already in factored form, these are more like the 3.0 problems, so your zeros here are at -1, 2, and 4. Oops. And then as we talked about, what you're going to want to do is you want to graph nice points to make sure that we got. And again, do not go through and I would say label on your x-axis or your y-axis yet until you see what the values for f of x are going to be, how what the scaling is. So you want to go left of your leftmost zero, somewhere in between your zeros, so that'd be 0 and 3, and then someplace to the right of your last zero. So if I plug in -2 in there, I'm going to get a -1 because -2 plus 1 is -1. -2 minus 2 is -4. -2 minus 4 is going to be -6. And so that's going to give me a -24. If I plug in a 0, I'm going to get 1, -2, -4, which will give me 8. Plug in a 3, I will get 4, 1, -1, which will be -4. And if I plug in a 5, that will give me 6, 3, and 1, which would be 18. So if I count by 2s, that should be fine. So that'll be 10. This will be -10. Now, obviously, over here, over on the left-hand side, when I plot down -1, oops. So when I plot -2, that's going to be down here somewhere in 24, somewhere down here. 24, just so long as that you've got it, it's off the graph, you're okay with that. So it's going to come up to 8. Now the thing is that remember this 8 isn't halfway through. So when you come up, do not do something where you're going to come up and just come back down like this, because it's not going to, since that's just the beginning of the curve, it's actually going to go up higher and come on back. So either plot extra points or give yourself a little bit of freedom there with that one. On 3, you're going to go down as far as -4, and then on 5, you're going to go up to 18. And so your curve is going to come up through here, come up, come back down, and go up like that. Please make sure that you continue it off the graph. Please make sure you put arrows on it, etc., etc. Part 2, this is going to be the ones where you factor out a common factor. This is unfactorable, so you're going to have to plug it into the quadratic equation. When you do this, you're going to end up with either, well, probably, since it's not factorable, you're going to come up with either irrational answers, in which case get a decimal equivalent and graph it, or you're going to come up with imaginary answers. This one happens to be imaginary, so I'm not going to worry about having you guys graph that. On the reality check, I'm going to make sure everything is graphable, though you may have to round decimals. This one's factored 3.0, so again, your zeros are at 1, 3, and -2. This one is going to have a multiplicity of 2. So that means that, remember, when that happens, it's going to act kind of, if you looked at it in isolation, it's going to look like a parabola, so it's going to bounce off of it. And you'll see that when we start plugging in points for it as well. Plot out your points. Make pretty points. So -3, 0 would be good. Let's see what else. 2 and 4. So -4, -6, -1 squared, so that's going to be 24. That's a big one. If I plug in 0, get -12. It's going to be +12. And again, that's going to be, if you look at where -2 is happening, since you've got 2 units on the left, I'm going to be starting way up here. Again, so let's count this as 10. Down here is -10. It's going to come up, and then it's going to come down. Grab my magic. It's going to come down, and then it's still positive values up here, and then it's going to come down and do something like that, which makes sense because it's a 4th degree graph. Let's see. 2, you get 1, -1, 4 squared, so I get -16. And with 4, 3, 1, 6 squared, so you're going to get a wonderful 72. So in terms of plotting them, up here, you're going to come back up, as we said, bounce off of 0 and come up to 12. Go through 1, come down to negative 16, come back up through at negative 3, or positive 3, and then you're going to go way up high on that. So it's going to come down. And remember, no sharp corners. Make them nice and curved. We don't want to hurt anybody on this. Next one, again, greatest common factor. 1/3 x to the third can be pulled out. So then this is going to give you, this is going to factor out to be x minus 1 squared. Negative 1, when two numbers multiply out to be 1, they have to be negative 2, negative 1. So you have zeros at 0 and 1. That's cubed. So when you're looking at the 0, oops, forgot positive 1. So at the 0, you're going to get a twist like a cubic equation. For the positive one, you're going to get a bounce. And that's good to have in the back of your head. So I've got to, now the other thing here about this, which is interesting, is that since they're so tightly and close together, you may want to actually put your scale like that. So you've got some room to actually, count things out. So I've got a 0 here at 0. I have a 0 here at 1. When you're plugging in points, now this is going to be positive, so general shape. You're going to come up, twist through this, come back down, and bounce off. Because since it's positive, it's going to end up and go from there. But we want to have a more accurate graph than just a flash in the pan. Handwritten one, oops, that's going to disappear on me. So, pick negative 1. So in that case, it's going to be 1/3 times negative 1 cubed times negative 2 squared. So that's going to be what? Negative 1, negative 1/3, negative 4/3. Pick like 1/2. So I have a good one in between. So that's going to be 1/3 times 1/2 cubed. So that's going to be 1/8 times a negative 1/2 squared. So that's going to be really dinky. So what? 2 times 2 is 4, times 8, 32, times 3, like 96. So that's going to be a very, very small bounce that's happening in between those two, which isn't surprising. And then for your last one, we're going to pick, let's see, 2. So we get 1/3 times 1 cubed. Excuse me, times 2 cubed. I got ahead of myself. Times 1 squared. So it's going to be 8/3 again. So in terms of scale here, that's about 2 2/3. So if we make this top up here 3, bottom down here negative 3. So that should give most of it. So you're going to come up here at negative 1. You're going to be at, what we say, negative 4/3. So that'd be negative 1 and 1/3. At 1/2, we're going to have this really little bump here. And then the 2 coming out, you have 8/3, which is 2 and 2/3. So you got this up here. So when you come up, you're going to come up through here, twist through it, come up, then bounce, and then come back up through here. Okay. But again, the important part is if it's cubed, you need to have that little twist going on. Last one, you got to factor this out. You need to find the factors of 4/2, so that's going to be plus or minus 1, 2, 4, 1/2, and then you got 2/2 and 4/2, which is already in the list. So again, synthetic division, or check your graphs. See what you come up with. Hey, this may work. Straight out of the box. So one of your zeros is going to be 2. And And then down here, you've got 2x squared plus 5x plus 2. So you say, what is that going to factor into? You for sure have a 2x and an x. You have a 1 and a 2 in the back end, so the 2 has to be here. So you got 2 times 2 is 4x, and then you get the 1x in the middle. So you get 5x. So then you've got two other zeros here. You've got x also equals a negative 1/2 and negative 2. And then you're going to go ahead and graph that like what we did before. So I'm not going to go through that since we just did a whole bunch of that. Graphing these. Again, remember what you're going to do is you're going to write this stuff in factored form first. So you have zeros at -1, 0, and 3. So that's going to give you in factored form that. Remember, you've got f of x is going to equal, and we've got the scalar out here, and that's where the 2 and the 3 are coming forward. Because again, we need to lock this into a specific graph because there's an infinite number of graphs that can go through -1, 0, and 3. So you're going to plug -3 in for f of x. A we don't know, so we'll leave that there, and you're going to plug the 2 in for the x. So that's going to leave you with -3 is equal to a times 3 times 2 times -1. -3 equals -6a, so a is going to equal 1/2. So your final equation that I expect you guys to write, and I'm going to assume that you guys can still have the skills from first semester and are able to multiply this out if need be. Is that? This new microphone picks up everything, doesn't it? Anyway, last one here. This, again, since this looks like a parabola, hit it when you're looking at just the 0. That means 2 happens twice as a 0. And then you've got -1 over here. So factored form, it's going to be this. Putz. I just lost the eraser. So I get f of x is equal to a times x minus 2 squared times x plus 1. You got a point in here, so this is going to be your f of x value. 3 in for x. So then a is going to equal -2, which isn't surprising that it's negative because it's finishing going down, which means it's going to be negative. So your final equation, before you multiply it out, would be this. Ta-da! And that should get you through most of the 3 and 4.0 stuff. The 5.0 story problem is really just more or less a graph it and see where it's decreasing or see where the maximum is, that type of thing. And again, we may also cover other ones like that where I may ask you a little bit more in-depth questions about roots and how they work and things like that. Anyway, hope that helps. If you have questions, give me a text or an email. See you on Tuesday.